explain about Thicken and Extract Edges command. First, Thicken command converts a surface into a 3D solid with a specified thickness. A useful technique for modeling a complex 3D curved solid is to first create a surface and then convert it to a 3D solid by thickening. If you select a mesh face to thicken, you can choose to convert the mesh object to a solid or surface before completing the operation. First, you should select surface to thicken. Specify one or more surface to thicken into solids. For example, thickness sets the height of the thickened object. For example, 20. Another one, this surface and this surface plus interval spacebar 10. Now I want to explain about Extract Edges command. Create wireframe geometry from the edges of a 3D solid surface, mesh, region, or sub-object. With the XH command, you can create wireframe geometry by extracting all edges from the following objects: 3D solids, 3D solid, history sub-objects, meshes, regions, surfaces, sub-objects. Press and hold Ctrl to select faces, edges, and component objects, repeating if necessary. Objects such as lines, arcs, splines, or 3D polylines are created along the edges of the selected objects or sub-objects. For example, select this object, press Enter. In the next session, I want to explain about other solid edit commands such as Extrude Faces and Sperate Faces or surfaces. Hello, in this session I want to explain about Extrude Faces and Sperate solids. First, this command, Extrude Faces. Edits faces and edges of 3D solid objects. You can extrude, move, rotate, offset, taper, copy, delete, and assign colors and materials to faces. You can also copy and assign colors to edges. You can imprint, separate, shell, clean, and check the validity of the entire 3D solid object. You can't use solid edit with mesh objects. However, if you select a closed mesh object, you will be prompted to convert it to a 3D solid. Face edit selected 3D solid faces by extruding, moving, rotating, offsetting, tapering, deleting, copying, and changing their color. Extrude extends a 3D solid face in the X, Y, or Z direction. You can change the shape of the object by moving its face. First, you should select the object, for example, this face. Press Enter. Specify height of extrusion. Sets the direction and distance of the extrusion. Entering a positive value extrudes the face in the direction of its normal. Entering a negative value extrudes the face in the direction opposite to its normal. For example, 20. Angle of temper for extrusion. Specify an angle between -90 and +90 degrees. Tapering the selected face with a positive angle tapers the face in and a negative angle tapers the face out. The default angle 0 extrudes the face perpendicular to its plane. All selected faces in the selection set are tapered to the same value. If you specify a large taper angle or high, you can cause the face to taper to a point before it reaches the extrusion height. For example, 30. Or I want to select path. Select faces and path. Sets the path for extrusion path based on a specified line or curve. All the profiles of the selected face are extruded along the chosen path to create the extrusion. Select extrusion path. Lines, circles, arcs, ellipses, elliptical arcs, polylines, or splines can be path. The path should not lie on the same plane as the face, nor should it have areas of high curvature. The extruded faces starts from the plane of the profile and ends on the plane perpendicular to the path at the path endpoints. One of the endpoints of the path should be on the plane of the profile. If not, the path is moved to the center of the profile. If the path is S-spline, the path should be perpendicular to the plane of the profile and at one of the endpoints of the path. If not, the profile is rotated to be perpendicular to the S-spline path. If one of the endpoints of the S-spline is on the plane of the face is rotated about the point. Otherwise, the spline path is moved to the center of the profile and the profiles are rotated about its center. If the path contains segments that are not tangent, the object is extruded along each segment and then the joint along the plane is mitered. Bisecting the angle formed by a segment. If the path is closed, the profile lies on a miter plane. This allows the start and end section of the solid to match up. If the profile is not on the miter plane, the path is rotated until it's on the miter plane. I want to choose this path. Move, rotate, offset, taper, delete, copy, color, material, undo, exit. Move moves the selected face on a 3D solid object to a specified height or distance. You can select multiple faces at one time. You can change the shape of the object by moving its faces. This option is recommended for minor adjacent. Rotate. Rotates one or more faces or a collection of features on a solid about a specified axis. You can change the shape of the object by rotating its faces. This option is recommended for minor adjustments. Or offset. You can copy faces. Specify a base point. can delete faces, rotate faces, or color faces, or taper faces, for example. Specify the taper angle. Now I want to explain about another command, separate command. Separates 3D solid objects with disjointed volume, sometimes called lumps, into independent 3D solid objects. Combining discrete solid objects using a union operation can result in a disjoint volume. A union or subtract operation can result in a single 3D solid that consists of the more than one continuous volume. You can separate this volume into independent 3D solid. Separating solid doesn't separate Boolean objects that form a single volume. With union command, all of the objects is one object. So with the separate, select the 3D solid and specify the 3D solid objects to separate. Press Ctrl plus click to select the edges. Shelling creates a hollow, thin wall with a specified thickness. You can specify a constant wall thickness for all the faces. You can also exclude faces from the shell by selecting them. A 3D solid can have only one shell. New faces are created by offsetting existing ones outside their original positions. It's recommended that you create a copy of a 3D solid before converting it into a shell. That way, if you need to make significant modification, use the original version and shell it again. Offset, for example. Enter the shell offset distance, sets the size of the offset, specify a positive value to create a shell to the inside. Perimeter of the solid, specify a negative value to create a shell on the outside perimeter of the solid. Clean. Removes shared edges or vertices having the same surface or curve definition on either side of the edge or vertex. Removes all redundant edges, vertices, and unused geometry. Doesn't remove imprinted edges. In unusual circumstances, this option removes shared edges or vertices having the same surface or curve definition on either side of the edges or vertex.